Good evening, everyone. We are going to get started. Thank you so much for being here. My name is David Glassner. I'm the superintendent of the Shaker Heights School District, and we are thrilled to have this opportunity to speak with you, learn with you, and talk with you this evening. This is part of our superintendent series on detracking, which is an opportunity to engage with and educate our community about the fantastic work that is happening in our school buildings. This evening, we are going to be sharing with you an immersive classroom experience specific to math learning at the middle years level. So if anything I'm saying sounds surprising to you and you're in the wrong meeting, you're still welcome to stay. There are a couple of just logistic notes. First of all, we are recording, you can see in the back there, because we want to make sure that we're able to share this evening's opportunity with folks who couldn't be here this evening. Also, a big thank you to our middle school staff, faculty, and administration for helping pull this together. I want to recognize Mr. Tom Flood, our middle school principal. Thank you, Mr. Flood, for being here this evening. And you'll get to meet some of our middle school teachers as well over the course of this evening. I also want to recognize Heather Weingart, one of our Board of Education members who's here this evening as well. Thank you so much for being here. So these opportunities are a chance to learn about what our classrooms are like on a regular basis. I do want to just point out a note. This evening is meant to be a simulation. There are going to be lots of things that are very similar, or if not exactly the same, as a regular classroom. And there are some things that our teachers will help explain to you as you go through this evening. When we finish in the library, we are going to go out into the hallway, and you should have on your name tags a room number. There are folks who will help guide you or direct you towards those classrooms so that you know where you are going. Just to give you a sense of a typical middle schooler's day, they have 4 minutes to get from one classroom to another. We figured since you have longer legs, we'll give you 3 minutes. And our middle school principals and assistant principals will be around giving lunch detentions to anybody who's socializing in the hallways. I'm kidding. That's not part of the simulation this evening. We are thrilled to have Brittany Webb, our gifted intervention specialist who works in our K-4 buildings and also a math teacher in our district, help share with you some of the work that teachers do together and some of the support that teachers get, kind of as by way of introduction for our evening tonight. So turn it over to Brittany. Thank you again, everybody, for being here. We're looking forward to our learning and conversation this evening.
Thank you, Dr. Glassner. As Dr. Glassner shared, I am Brittany Webb. This is my 9th year in the district. I spent my first 7 years at Woodbury teaching math. I'm sure I may have had some of your children before. I do see a lot of familiar faces. The past 2 years, well, the past last year and this year, I've taken on a new role. I am the gifted intervention specialist for the K-4 buildings. So I am in all 5 elementary schools, and I get to see what's going on in the classroom. So I shared some information at the past Shaker Schools Foundations meeting with our board members, and they really felt like parents should hear what I shared, and I'm going to share that information with you all. So this is how it kind of began, right? Detracking, where we can imagine like kids not doing what they should, one teacher, there's chaos going on. How are our children getting fed? How are they getting challenged? How do we put this on the teacher, right? Teachers need support. And I feel like the district heard us when teachers requested assistance. We need help. Detracking and why it's important. I think the 2 biggest takeaways is, number 1, research shows that detracking leads to segregated classrooms. That's the biggest issue for me, as well as we don't see as much growth in our at grade level and below grade level classroom, our students, as compared to detracked classes. So those 2 points, tracking leads to segregated classrooms, as well as our students that are in the core classes aren't getting what they need when we have tracked courses. So speaking of what the teachers are getting in this Detracked model, they have the supports from our IB coordinators. So IB coordinators are at every K-4 building. They assist with the units of inquiry. They pull students for discovery lessons 4 times per year. I was just at Onaway, and the 4th grade students did the egg drop, which was it was exciting. I had never experienced it. They also help connect the curriculum with real life experiences. So they organize the field trips to the nature center, they invite guest speakers, and then they bring in community partners to just enrich the curriculum. Instructional coaches. So they meet with the teachers to help create, plan, and implement effective strategies. They co-teach and model with the teachers. They help create materials that correlate to the state standards and to maximize engagement, and they assist teachers in navigating new resources. We have a new Bridges curriculum, which is the math curriculum, and there's an extension that we just got our hands on for 3rd and 4th grade math students. So we will have that opportunity to explore those components and allow the teachers to delve in and see how they can best fit it or embed it within their everyday lessons. PBCs, these are positive behavior coaches. These coaches are at the K-4 buildings. So they assist and model effective classroom management strategies. They share resources with the teachers as far as how to build relationships and help de-escalate behavior situations. They help teachers to develop practices to improve classroom behavior. And they also work one-on-one with students that may need extra supports. I noticed at Fernway, they have these feeling mats in the hallway. If one of the students feels like they can't self-regulate or needs a moment, there's a mat on the wall in the hallway, and it has just different nonverbal ways to communicate their feelings. So they'll point to a feeling and they'll do an exercise related to feeling frustrated, or they'll point to another feeling and that they're feeling and then do another movement that helps them just calm themselves, reset, and make their way back to the classroom. Literacy specialists. Now this is at the K-4 level, but these are highly trained staff members with extensive knowledge in literacy that work directly with the teachers. They push in and they work with small groups of students. So this is another resource that our teachers have. And then we also have the science of reading curriculum. We have letters training, we have gifted training, we have dyslexia training, we have Haggerty Bridges to Reading curriculum. Like, these are all trainings and these are all different curriculums that our teachers are receiving in order to support them in this new Detracked model. So they are getting the support. Can we do better? Is there more to do? Yes. But for year 3, I think that we're on the right path. So this is what we have. This is just a glimpse of what I've seen in the classroom. I've seen teachers dedicated to this model of detracking. I see it working for the students at the elementary level. There is also a gifted intervention specialist here at the middle school and Woodbury, as well as the high school, and she's seeing these things also. So I just wanted to just take a moment to give you guys an idea of the supports: IB coordinators, instructional coaches, behavior coaches, as well as gifted training and all sorts of training to support our kids in the classroom. So with that being said, speaking of classrooms, We are going to sort of merge out in the hallway and we'll get our immersion experience.
All right, well, welcome. I'm Jenna Peltz. I'm the 8th grade Algebra 1 teacher.
And I'm Katrina Holmes. I'm the intervention specialist, and we co-teach 3 periods together. It's our second year co-teaching also.
So it's my 17th year and
My
it's
15th year teaching.
All right,
So yay.
So we're just going to first talk through what are you doing today, what are the expectations, and then we'll go through 2 rotations so you can get a little taste of both stations. And then your homework is either level 1 or level 2 worksheet on some equation solving and real world application problem practice.
Okay, so we want to change the slide. So we're doing 2 rotations, but 3 different stations. So the group that's going to be at the vertical whiteboards over there, which it looks like we have at least 2 groups, your goal is to solve at least, we should have added at least, Mrs. Peltz, 3 equations. And the idea at the whiteboards is the person who is talking gets to choose the level because you're the one telling the person who is writing how to solve the problem. So if you're not as comfortable with equations, you might want to start with, we have 3 different levels. We call them
Mild, medium, spicy. So if I'm a little weaker in equation solving, I may choose a mild equation to solve and I have my answers here, but I'm the one choosing that problem to explain that one to my partner while my partner writes, maybe gives me some feedback, corrects things as I go. And then when it's my partner's turn, maybe they want to choose a medium or a spicy problem so that they get to explain a problem at their level. And hopefully their partner is maybe learning a thing or 2 along the way if that's not at their level.
And then also, while you're over there, you will have yesterday's notes that you took
So we have
on
your notes
solving
here
equations
for you in case you left them.
and a calculator.
Yes.
And then the group in the back is going to be working with me on some reteaching, some repeated practice. You might not have scored as well on your last formative assignment, and we are going to do some extra work to kind of get you going a little bit.
And we would not tell them that, but
Yeah. And then the group in the front is doing a
so we're doing a whole group lesson, learning a new topic, and it's going to be solving equations in real world context. So we're setting up equations and solving together. So everybody will get this lesson, but not everybody will get to go to the whiteboards or get the small group reteaching.
Yep. All right. We ready to rock and roll?
All right. So, are we all good?
Oh,
so
wait.
we need a buddy up there.
And we forgot the criterion for success.
Oh my gosh.
Sorry,
Okay,
guys,
let's
for falling apart
pause
on
for a
you.
moment. All right, so today we are practicing equation solving at many different levels so that we can set up and solve real world application problems, and we'll know we have it when we can complete the practice assignment at our level. So partners over here, we'll just go with you 2. We would have a little bit more strategy to this, but you 2 can go up to board 0 and you 2 can head over to board 1. One person grab the marker and go ahead and get started. Remember to do at least 3. You can keep going. Keep your volume down though, because we are running 2 other groups, so we don't want to interfere with some of the other discussion going on.
All right. And then you guys are going to we're going to go over a reteaching on how to solve 2-step equations.
So we're going to practice defining variables today. We're going to write an equation and solve it algebraically. So in doing this, we're going to each grab a highlighter and we're going to practice highlighting some clue words that are going to help us to translate this equation or this sentence into an equation. So you have a little reference sheet here. You can check in with some other clue words for like addition, subtraction, multiplication, division.
Solving an equation, I'm going to read the top. Solving an equation means finding values that produce a true statement when they are substituted in for variables. You can solve equations by applying the properties of equality to produce equivalent equations that have the same solution as the original equation. So we've been talking about properties of equality. They know that, addition 1, the subtraction 1, the multiplication, and the division 1. I would also like to add, and if you want to write it off to the side, you can, inverse operation. So that's how we solve, if you guys remember from math, inverse operation.
So remember the formula for perimeter, that's the 2 the first two problems we're going to do are involving perimeter. P equals 2 times the length plus 2 times the width. So we're first going to take we'll read through it once, then we'll do some highlighting and underline second. So the perimeter of a rectangle is 400 meters. The length is 15 meters less than 4 times the width. Find the length and the width. So we're going to highlight some of these important mathy words like perimeter. Is actually, think about a math word translating to equals. The length is 15 meters less than 4 times the width. So let's have a quick discussion. What are some of the operations we might be doing in this problem? Like, what do you think less than might be? If you look at your paper, if you're not sure, your reference sheet, what do you think less than might be? Go ahead. Go ahead. Subtraction, and then 4 times the width, maybe we're involving some multiplication. All right, so anytime we see the word is, let's write an equal sign up above it just to kind of help guide how we're going to set this up.
We're going to do the one example problem together, and then we're going to do, I might skip depending on the time, I might skip the interactive example, and we'll jump to do the math example, okay? So the other thing I like about this is we're not just teaching them or working with them on the algebra skills, like the actual skill it takes to solve an equation. We're starting with it within context. So I kind of like that when it comes to teaching equations, so you know where those numbers came from. They're not just random. So Janie already has 37 books in her collection and plans to buy 12 books per year. If Y is the number of years Janie has been buying books, solve the equation to find how many years it will take her to own 193 books. So we already have the equation here. Oh, sorry. We already have the equation. 37 plus 12y equals 193. And what do you think we moved to get to 12y equals 156?
So I'm going to start with my 400 meters, because that's our perimeter P.
And did we add it or subtract it? Good. So there's not a lot of room on there, but if you want, you can squeeze in a minus 37. We know this cancels out, and we're left with 12y equals 156. And on the paper, it does say subtraction properties of equality. Now, how do you think we got to y equals 13? Divided by 12 on both sides. So y equals 13. Now, taking it into context, what does the 13 stand for? What does that mean? The number of years. So we might have to maybe write out, it will take Janie 13 years to accumulate 193 books. So this is a nice scaffold version of it, kind of gives them the problem already solved, and then we can talk through each of the steps.
So if we're going to define the variables, we're going to define everything in terms of one variable. We're not going to have two variables for length and width, because so far we've only learned to solve an equation with one variable. So for the length, we're given the length is 15 meters less than 4 times the width. So I'm taking 4 times the width and then subtracting something from it. So I want to write 4 times the width minus 15. And so because we're putting it in terms of width, then W is just going to represent the width here. So off to the side, we're going to sketch a rectangle to visualize what's going on. We're going to have our 4 sides. We're going to label 2 of the sides with the length 4W minus 15. And then we're going to label the other 2 sides as width. So there are a few different ways we could write the equation for perimeter. We don't have to stick with this. We could just add everything up if we wanted. We could do 2 times the length plus the width. We're just going to stick with this for now just to kind of all do the same thing together. But just know you are welcome to try a different strategy on number 2. So I'm going to start with my 400 meters, because that's our perimeter P. Let's change out this maybe green. All right, so we got 400 equals. How would I write 2 times the length? If we're saying length is 4W minus 15. How do I ensure that I double everything? If it's an expression, it's not just a single term. If you have a thought, raise your hand, how we might double the length here. You got something? Put it in parentheses, yeah. So we're going to do 2 times the 4W minus 15.
Reading the problem. Would anybody like to read problem number 1? Cheryl? Thank you, Miss Chin.
Cheryl has $1,500 in a bank account. She is saving for a car. Plans to deposit $600 into the account every month. If M is the number of months since she started saving, solve the equation to find how many months it will take Cheryl to save for a $12,300.
Okay, so important information that we might underline are, what do you think we need to know or need to use?
Divide by 10 at the end.
Starting with 1,500.
Okay, good.
We have our
Oops.
width is equal to
1,500. And then how much is she saving per month?
meters, always double check. And before we
600. Good.
we answered the question. So this
And then how much does that car cost?
find both the length. Not yet. So we
Good.
how might we
12,300.
figure out the length?
Now, I don't know what it is, but whenever I draw this line down the middle of the equation on the equal side, the kids automatically know what they need to do. It's amazing. Okay, so on our paper, we have 600M equals, and then we have a blank here. What did we, again, kind of like if we referred to the front page, what did we do to get rid of that $1,500? We subtracted it on both sides. And then you all have a calculator. What is 12,300 minus 1,500?
So let's check, does this make sense
You guys,
in our problem?
you guys can use your calculators. Oh, that's fine. You can do that.
157, we could double check. Add those up.
Has anybody got it in their brain?
Seems like
10,800.
Very nice, Miss Dr. Glasner. 10,800. And then, so we would fill in the 10,800 in the blank, and then what property of inequality did we use again to get to there? So we did subtraction, good. Okay, now we need to get down to M equals. That's our last step. So just like on the previous page, how do we get that 600 away from that M? What inverse operation would we do there? Division, good. Would you divide by 600 or the 10,800? Okay. Okay. And that would be 18 months. I won't make you guys exert your brain anymore. And what would that be? What would the context of that be?
So if you isolate it,
It'll take her 18 months to save up.
it's like 3x.
Yes. Good. So 18 months to save $12,300, and then we would write that out. Now it's your turn to do some practice. So I want you to definitely see if you can do, although did her timer go off? No, I have 3 minutes. Try number 2. If you need some help with the fraction, I can help it with you guys. Or skip around and see which ones you know how to solve. And I'm going to go check in with the vertical whiteboard people and see if they have any questions.
And then we're going to add 2 plus 2 times W, so we'll just add 2 times W. So the big thing there, I usually see some misconceptions or some common errors are not doubling the whole thing. Remember to take 2 times the whole expression. So now we're going to use our equation solving, and go ahead and if you want to work through this at your own pace, go for it. I'm going to go through and distribute first. 400 equals 8W. 2 times 15 is minus 30. And pause for a moment. Just one of the things we like to do is combine the like terms before we start to move our terms from one side to the other. So do you see any like terms here? Anything that we could combine that have the same variable? The W's, yep. So we're going to combine 8W and 2W. So now we have 10W. So go ahead and bring everything else down. And at this point, you know how to solve this. So it's just an easy two-stepper. We're going to add 30 to both sides. And go ahead and finish this off. If you need a calculator, it is there for you if you need it. So we'll divide by 10 at the end. And we have our width. So width is equal to 43 meters. Our unit of measure is in meters. Always double check. And before we move on, let's make sure we've answered the question. So it says find the length and the width. Did we find both the length and the width yet? Not yet. So we have the width. How might we use the width to help us figure out the length now? Think about how we wrote our length in terms of the width. Where might we plug this in? Hopefully we're thinking we would go back into the length expression here. We're going to do 4 times the width and then minus 15. So go ahead and use a calculator if you need it, but length equals 4 times 43. Just substitute 43 for W. And minus 15. All right. So if you could plug that in, let me know what you come up with. It is 157. If you wanted to, you could plug that in, 4 times 43 minus 15, and label meters. So let's check, does this make sense in our problem? We have width, 43. Length is 157. We could double check, add those up, and it should equal 400. It seems like that would work out. All right, so it is reasonable. So take a moment. Now you're going to try number 2. You're going to first start off just thinking through this for yourself for about a minute. All right, so read it to yourself. See if you can define your variables. Maybe sketch a picture or write the equation. So after the minute, I'll have you buddy up with your partner, and you can discuss and try it together. So use that first one as your model.
8 minus 2 equals 10, so then you have to break this down to make it 10.
So remember to use your clue words if you're stuck, like more than, maybe find that over here if you need it.
What would that be? What would the context of that be?
How are we doing over here? Okay.
2 more than 3 times the length.
2, yep.
So 18 months.
3 times, yep.
Okay.
All right, see if you can set up your equation. So now go ahead and check in with your shoulder partner. So check in with your buddy. If they're stuck, see if you can maybe get them on the right track.
Try number 2. And if you need some
Yeah.
or skip around.
Oh, we're right.
We're not doing it right.
So we want to, if you sketch a picture, it might help you to visualize that you have those 4 sides. You want to make sure you have all 4 parts as you're setting up your equation. All right, so what I'm going to do now, well, I would give you a few more minutes to try to debrief and discuss and figure it out, but could someone share out how they define their variables? Just, what did you write for length? Going back to this one says the width is 2 more than 3 times the length, so a little bit different in how you set it up. Is there a volunteer who would like to share? Any takers? Brian? Oh, go ahead.
We did it based on the length.
Okay, so how did you write that?
Length equals L.
Yep, length equals L. 2 plus 3L, yep, and you can have 3 plus, or 3L plus 2 if you want to switch the order. So good, that's our first key part to figuring that out. And then the rest, you can refer back to your formula for perimeter. We would start with replacing the perimeter. So what could we write as our equation? Because sometimes the setup is the hardest part. So how could we write our equation plugging in everything we have? Brian, you want to share what you had? Looked good. Okay, and what did you put for P? What did you replace? 100, okay, 100 equals 2L. All right, so plug in 2 plus 3L.
Well, I think just the.
All right, and we would go ahead and distribute combined like terms, same thing we did above. So answer you're looking for, if you did get it, was 12 meters and 38 meters. Okay, so 12 meters by 38 meters. All right, so that would be our length and our width. And again, you could double each of those, add them up, make sure they add up to 100. So we're at the point where we're going to rotate. We would, in theory, do the back together, same kind of setup. And there would be a homework assignment that I would give you. But if you want a copy of it just to be able to kind of see, I'll give you our level 1 and our level 2 options.
Thank you.
So if you're feeling unsure, maybe you're sticking with level 1, level 2. If you're ready for more, definitely try the back. Or if you want to do a little blend of both, you could do some level 1 and some level 2. All right. So at this point, we do need to switch. I'm still working on developing that.
All right. So we've been talking with the kids about these properties of equality. So they're familiar with that vocabulary word. They know that there's addition, subtraction, multiplication, and division. But we also teach them just the inverse operation. And the inverse operation is like the opposite of addition is subtraction, and the opposite of multiplication is division. So to undo an equation, you have to work backwards. And it can go that way too.
All right, so up front here, we are going to practice the equation solving, but in some story problems. So still trying to use inverse operations to solve, and all those algebraic skills of looking to use properties of equality, inverse operations, and so on. So for each problem, we're going to define our variable, write an equation, and then look to solve it algebraically. So although you may maybe you might be one that can figure it out in your mind, but we want to see the algebraic process written out. So you're going to grab a highlighter. We're going to underline some clue words. And if you're not sure of those clue words, what they mean, we have a reference sheet here for other words for maybe addition, multiplication, subtraction, and division if you're still working on developing that skill of translating the words into algebra. So we want to remind ourselves of the formula for perimeter. It's P equals 2 times the length plus 2 times the width. Do you need a copy of this? Do you want? Okay. Okay, you're, all right. All right. So as I'm going through, I'm going to highlight some things, and maybe you want to highlight a different word, but I'm going to look for the mathy word so I can start to do some translating into our expressions to help me define the variables, and then we'll write our equation, and we'll include a sketch to visualize what's happening here. So the perimeter of a rectangle is, so definitely perimeter is important, is 400 meters. And the length is, every time we see is, we want to think of the word equals because it's telling us something about something that's equal to something else. So 15 meters less than, so definitely the phrase less than we'll highlight, and 4 times the width. So we're asked to find the length and the width. All of our equations that we're seeing right now, we're writing our equation in terms of one variable. We have not learned how to write an equation with 2 variables yet. So we're trying to write our length in terms of the width here. So take a moment, see if you can figure out the length, how we might write that expression based on our second sentence here. So use those clue words. Look at the reference sheet if you need it.
So let's skip down to the example. It says, Janie already has 37 books in her collection and plans to buy 12 books per year. If Y is the number of years Janie has been buying books, We're going to solve the equation to find out how many years it will take her to own 193 books. So this example, as you can see, is already worked out for the kids. So that's one, that's like, it's like scaffolding. So we start with a work problem and then a fill in the blank one, and then we'll turn them loose and do their own. So let's see, 37 plus 12y equals 193. And then they have this, 156. And then the kind of the giveaway is they have subtraction over there. So what did we do to get to this point? If we started from here and we got to this, what do you think we got rid of? Okay, did they, well, and they subtracted it, yeah. So I don't know if you want to, if you can squeeze that in there. Obviously, that gets us to there. And then the next thing that they have written down there is the y equals 13. And it says division. So we know that they had to do some division. And what did they divide by on both sides? By 12. It's coming back. And the one thing I like about this reteaching is that it puts it into, we're not just reteaching the equations, like how to solve equations, which is important, obviously, but there's, you know, an example. We can kind of put it into context with, you know, books and stuff like that. So what does 13 mean as far as Janie goes?
13 years.
Yeah, well, it'll take her 13 years to get 193 books, right? Okay. What did we do to get to this point? We started from here and we got to this.
All right, check in with your neighbor real quick. Maybe you're unsure, you just want to feel confident. Check in to see if they figured out how we might define the length.
So I don't know if you want to, if you can squeeze that in there.
And if there's anyone who might be willing to share out, maybe Benjamin. What did you, I see something that looks good on your paper. How'd you write the length?
4W minus 15.
4W minus 15. Can you explain that real quick?
I guess so. Okay, so the length is 15 meters less than 4 times the width. So 4 times width is 4W minus 15, less than 15. There you go, that's it.
Good, so a common misconception is putting the 15 minus 4W, so we want to make sure we're taking 15 away from 4W. All right, so if we're putting this in terms of one variable, we're just going to use W for the width. So let's sketch our rectangle at this point. And we know that we have 4 sides, we have 2 lengths and 2 widths, so we're going to label 4W minus 15 along maybe the top, and 4W minus 15 along the bottom. And we have 2 widths on the opposite sides. Now, there are a few different ways you could set up this equation. We're going to use P equals 2 times the length plus 2 times the width. You could actually just add everything together, or if you wanted to do 2 times length plus width, that's another option, because really that's the same thing. We're doubling our length and our width. So if we're rewriting this equation with our information, we're going to substitute in 400 for our perimeter. So we're going to say 400 equals 2 times the length. The key here is that we're doubling the entire length. So it's not just one term. We want to make sure we are including parentheses around the whole expression. So we should have 4W minus 15 inside the parentheses. And then we'll continue with plus 2 times the width. And now we can practice our equation solving. So take a moment. At this point, we know how to distribute and combine like terms. So go ahead and answer this on your own. Check in with your neighbor. Take about a minute. If you're feeling like you need a little reminder, just call me over and I'll help you get rolling. Calculators are there if you need them.
don't know what P is. You know the number is what?
Almost.
Looks good. Looks good. You're on the right track. Oh, we need to solve it all. Yep. So go ahead and solve all the way for W.
Over to there, to the other side.
430 equals 10W.
Might not get marks for being organized.
That becomes a positive.
Is it 37?
So see if you can help your partner a bit in figuring out where they.
I think you come out more even.
Looks good. You
Couldn't see the chicken scratch. If W equals 43.
43. Yep. All right. How many of us got 43? How many of us got 43? Getting there. It seems like maybe if we did the next couple steps, we would be there.
Right, okay.
So I'll go through and show the work just in case you need to see where you may have made a mistake. So after we distribute, we get 8W minus 30. We'll combine our like terms.
Minus 15,
So 10W.
minus 15.
Now, could you do this differently? Could you have added 30 beforehand? Yes. We just want to practice simplifying beforehand. And then we have a nice little two-stepper where we can add 30 and divide by 10. So 430 equals 10W. And once we divide, we see now the W, the width, equals 43. So what's our unit of measure in this problem? How are they measuring the perimeter? Meters, okay. So label your answer. And then, did we answer the final question? We did not. So what part do we still need to figure out?
The length.
The length. Okay, so we know the width, we got that part, but we still need to figure out the length. Remember we wrote everything in terms of the width? How could we use our width to now help us figure out the length? Where could we plug that in?
W, 4 times 43.
Yep, in for W over here. So we're going to say 4 times 43 minus 15, and that's going to give us the length. So if you need to use your calculator, you can, or you could just trust me, and it's going to be 157 meters. So check the reasonableness of your answer. Does this seem to make sense? Width is 43. We have 2 of those, right? And then 157 for the length. We have 2 of those. We'd want to double check that that does add up to 400, which it does. So now you're going to try the whole thing from start to finish on number 2 with your partner. But you're going to first start off taking a moment for yourself to read through it. So we're going to do a little think, pair, share. So you're going to think about it for about a minute on your own. See what you can come up with. And then I'll tell you when you can check in with your partner.
All right, we're going to skip, because of time, we're going to skip this one and go to the back. Would somebody like to read this one?
Oh, go ahead. I do this to my students all the time. It's like, oh, crickets. Cheryl has $1,500 in the bank account. She is saving for a car and plans to deposit $600 into the account every month. If M is the number of months since she started saving, solve the equation to find how many months it will take Cheryl to save for a $12,000 $300 car.
Okay. And they gave us the equation, so we got that going for us. So 1,500 plus 600 equals 12,300? Okay, I should know this, I've already done it. And then they have 600 equals. And then you were supposed to identify what the properties of equality is. So what did we move?
1,500.
And we, opposite of that is,
Subtraction.
thank you, Miss Weisbard. Am I writing this right? Yeah. Shoot. Okay. You guys have calculators. What's 12,300 minus 1,500? 10,800? Nice. And off to the side there, we need to know what we did. We did the subtraction, properties of inequality. So if you want to abbreviate, for some reason I'm like leaning towards this side of the board. And they don't give us much else this time around. They only give us the M. Yeah. I feel like two-step equations are like the bread and butter of the beginning of algebra. Like, you need to know how to do a two-step equation in order to go further. And I think it's, what did I get? I got 18. And we did division.
Could you have added 30 beforehand? Yes. We just want to practice simplifying beforehand.
How
18 months.
it will take her 18 months. So we'd bring it back into the context. So now here, you guys can do it if you want to. You don't have to, though. Oh, I didn't set a timer. This is where I would have the kids go through and do this repeated practice of all the different equations so that we can they can start working on them to get the practice while they have a teacher around, somebody that can answer their questions or something like that. So you don't want to solve them. I will leave this up here as an example, but you have it on your paper, but I totally...
So is this like...
All right, go ahead and check in with your shoulder partner now. Time? Okay.
So the perimeter is 100, width is 2 more, and then 3 times the length, so I put 2W.
So we're going to need to wrap up here. All right. Oh, they're done. Okay. Oh, good. All right, so we're going to stop here. Those of you working, we're just going to transition over to the Q&A portion of this. So thank you for participating. You can keep your notes if you would like, or you could recycle them up front here. So we want to first talk about the why behind everything we did and some of the grouping and all of this background stuff. So the group that was with me would have been heterogeneously grouped. Everybody gets the same lesson in smaller sessions, though, so it's a little more one-on-one attention. I can help with questions, and it's just, a chance for more people to answer questions rather than maybe the same students always answering the same questions in a large setting. We're practicing reading skills where you're highlighting important clue words. We did a little think, pair, share. You used a reference sheet, which some students would get. Not all students would need it. Homework is differentiated. We would offer 2 different levels on the homework. Some may do level 1 on the front, some may do level 2 on the back, but some may do a blend of both. Sometimes we would encourage students to focus on level 2 or vice versa, depending on where we feel that they're at.
And then the vertical whiteboards.
Yep.
That particular group was homogeneous, but it typically can be totally random. We would just have, we would put their names into a spreadsheet and it kind of randomizes them and groups them. Or we can do targeted grouping. So I might, or Mrs. Peltz might note, like maybe we have a couple kids that needs a little bit more teacher support. So we would put them in a particular group and work with them on the whiteboard. We also, if you notice, we had if you were able to go over there, I'm sorry you didn't. The differentiated, the mild, medium, and spicy. So that way we're hoping to hit all those different levels that we have in this classroom. We have kids that are, struggling with algebra and kids that are, some of them are flying through it. And then it's also self-checking. So you don't necessarily need a teacher over there to look over your shoulder every step of the way, because you can check your answers. And if you happen to get something wrong, you could pull one of us in and we can check in with you. And then I'm going to let you talk about this. You do such a nice job.
So the vertical whiteboards are not something we made up. It's coming from this book called Building Thinking Classrooms, which is all research-based, but it's proven that it increases student engagement and communication, which we have definitely seen. The students are able to speak and share and explain their way of solving it, and in teaching their peers, they kind of learn it better themselves as well. It makes learning visible. We can see their mistakes more clearly as we're walking around as opposed to on a worksheet at their desk. And it really does put the thinking on the students as opposed to mimicking I do, we do, which is kind of what we did up here, but it does allow them that time to process and do it on their own before we, without them following our model that we had on paper. They can kind of think through it for themselves, so it's less mimicking.
And then if you were in my group back there, again, that was a homogeneous group, you might not have scored as well on a formative assessment that we gave earlier in the week, and we want to kind of bolster up some of those equation solving skills by doing some reteaching, some repeated practice. And then also too, there was a lot of scaffolding in that worksheet. So that was very helpful to see, actually see a solved problem and how it should look. And I kind of talked about all of that. I just said all that, so we're good.
And these groups are flexible. We would change them up from maybe topic to topic or day to day. They're not always the same. And sometimes we have kids that are absent who need some reteaching, or sometimes it's just a particular skill that they need some extra help with. So
that's our
spiels. But do you got what kind of questions do you
can we
have
answer?
now? So go ahead.
Do all classrooms get the benefit of an intervention specialist?
No, I have 5 classes, and 3 of my 5 are co-taught with Mrs. Holmes.
So what happens in the other classes?
It's a good question. It's kind of a different plan. It's not totally different, but in this situation, I may do this lesson with everybody first for the first 15 minutes or so, and then we break out into 2 separate groups where I may run this station and this one is more independent. Or I may use video notes for the students up here. I would record the same lesson. Then it's also quieter, especially if it's a large group. They can watch the lesson up front here. I can then go check in or run a group over here. So it frees me up to do more and meet with students. Sometimes the whole class is doing video notes, and I can check in with more students, or maybe I'm running a small group. So we use video notes a lot to our advantage, and a lot of one station being independent to allow for more of the smaller groups.
And then also, the other nice thing the math department does, speaking of video notes, is they post to the Google Classroom that lesson every single day. So if a kid is absent, or if a kid's at home doing their homework and they're kind of struggling maybe with something, they can log into their Google Classroom, and there's a lesson over the notes for the day.
But it is definitely a challenge, especially if I'm in here by myself at 27. That is the biggest challenge. Sometimes we feel like we're all over the place. Okay, go ahead.
I don't know if I'm going to say this right, but how do you keep from tracking in a detracked classroom?
So the question is, how do we keep from tracking in a detracked classroom? Well, I'll be honest, I think there are times where everybody's together, but there are definitely times where there is some tracking going on to some degree to just get the students what they need. And a lot of times the students want that support. Go ahead.
Well, and I was going to add that the groups are very flexible. So, maybe a kid struggled with equation solving, but is doing really well with polynomials or something like that. So it's not like a kid is tracked in the classroom and can stay, would stay there. They can kind of, move in and out of wherever they, with whatever they need. So hopefully that is a positive thing for the kids.
And also when Mrs. Holmes talked about the vertical whiteboards, when we do the random groups, students are all completely blended together. So they do get many opportunities where they are all working together, especially as we introduce a new topic. But as we kind of move through the curriculum, through a unit, that's when maybe we start to see some separation where it just is, we need it to help the students. Yep.
Yeah, you may have gone over it, but so with the formative, you're offering a variety pack essentially, but the summative, which is the exam, right?
Right.
How do you what's the lay of the land for that?
That's a good question.
So the question was, on our formative assignments, we have variety, but on the summatives, it's kind of like we're trying to all reach the same standard. So we offer leveled assignments, leveled homework assignments, classwork. When it comes to the test, we also do have some leveling of the assessments going on, but that does help us to determine the best placement for the student moving into 9th grade. Do you want to add anything else, Mrs. Hagley?
I would also say, so there's 2 types of assessments we give. One is IB assessments, and typically our IB assessments are they look the same for everybody.
Yeah.
And then we have, and we'll give at least 1 or 2 of those every marking period. But then in addition to that, we might have more what we would, the typical maths, more skill-based assessment where we're looking at the variety of skills that students are doing and their application. And those are where you might have different types of assessments going on or different levels of assessments. And with our retake policy, if a student does poorly on one level and we see that they need to, do something differently, they weren't quite ready for something, then we can go back and kind of fill in those holes.
So like our level 2, for example, that's gonna maybe prepare them to be on the 9 math honors next year, whereas if they're doing more of our level 1 work, that's grade level, that's algebra ready, but maybe they need that to feel successful. So at that level, that allows them to learn more of the curriculum because they're not pushing themselves too much.
It's like, just to follow up, I connected on like the periodic assessment, like over time.
Yep.
But I'm thinking more of the, like within a quarter or semester type assessment across the board in the classroom. Maybe, I hope I'm not repeating the question, but it sounded like there's sort of like, where do you stand, the lay of the land relative to where you might be going in the future, which is what kind of that IB assessment thing looks like. But I'm thinking of like, you work on a lesson and then you have, multiple formative assignments and then, maybe 2 weeks in you have the summative. And so if I understood you correctly, within that summative, there's a range of difficulty that you can attempt. There's grade level, and then if you want to go beyond grade level, the student, if they have the time, they do that as part of that.
On our IB assessments, yes.
But on the IB,
that's more of how those are structured, where they see all levels, but
day to day, or maybe
more day to day, like even our quizzes, which are our formatives, our checkups, we have different levels of those as well.
Okay.
And then we make adjustments from there as we move closer to the summative.
As a class or within?
Oh, individually.
Based on the student.
Based on the student.
And we make comments in the grade book, so when we put in their formative or their summative, we'll put in what level they were successful at.
Gotcha.
But they all get the same testing, and then you assess the different levels based on that similar testing across the board.
Yes. Yeah. Go ahead.
How do you ensure that a student who maybe could be doing spicy or level 2 isn't always choosing the easier options?
Yep, so the question is, how do we ensure that the student is selecting something more at their ability, more so than what they just want to do? So if they're, we would first off have a conversation with them if we start to see, hey, I see you're always, going for the level 1. I think you should maybe try some of the level 2 and see how you do. And we would eventually maybe involve their parent and say, we think they could do a little bit more. Could you encourage them? So we would eventually, like in the beginning of there, we say you can choose. But eventually, as we see their ability, we would urge them firmly to try some of the other.
Like we would hand out the homework and
levels.
we'd say you're doing level 2.
Yes.
Okay. So, and we would expect that of them.
How do you decide who is deemed level 2 appropriate?
We would use a few things. I mean, we would look at their homework. Sometimes they're consistently trying level 2, and sometimes we'll ask them, do you think you're ready for you want the level 2 assessment or you want the level 1? Sometimes it's based on what we see and hear. They're always answering questions in class, or their MAP scores show that they're definitely capable, but we wouldn't use that all the time because different topics don't necessarily aren't reflective in their MAP score. So, and sometimes that changes from unit to unit. So they may be level 2 in one, but they may be level 1 in a different unit. So that does change over time too. Yep.
We just went from 4th to 5th grade, and so one of the things that I noticed is that there's no more support of like Dreambox, where the student keeps learning at home.
Okay.
Past the level of what's being taught in the classroom. We don't have that anymore in 5th grade. Is that something that continues on throughout school?
So the question is if a Dreambox is no longer offered as from the change from 4th to 5th grade?
Yes.
And so you want something extra at home as a
I'm not
support,
saying I
or,
want it,
okay.
I'm asking, like, is it no longer encouraged after 4th grade that students continue learning at home at their own pace?
It's just a different application. It's called Waggle this year.
My son swears he's not supposed to do it at home.
Oh.
Because people do. It's pulling my leg.
He is, yeah.
Okay.
I think different computer options are at different grade levels. So we have Delta Math for our 8th grade algebra class. Did you want to add something, Dr. Glass? Oh, I thought you, Dr. Glasser, I thought you were saying something.
Actually, I was
Okay.
in a 7th grade classroom for the last session, and they mentioned Delta Math also.
Okay.
And that sounded like it was something that it was expected to be done
Like-
at home.
Yes.
I was going to say, don't you have a student that,
So for a student who I have who is gifted, this current unit that we're in, she seems to know a lot already. So as she moves through the work and she finishes early, I have created an individualized Delta assignment specifically aligned to geometry standards, which according to her MAP score, geometry was her lower strand. So she does that if she finishes early. It is an independent assignment, but different units lend themselves to other activities and extension work. So some students may, like in certain units, they may just have an opportunity to do more in a small group in those gifted clusters. I know that was your original question, but
I learned a lot today.